Hello everyone. So now we're going to solve the question median in a data stream. And now that I say that, okay, this belongs to Heaps playlist, you're not going to understand why, how, what is its approach. So once I've explained you the approach, once I've explained you the problem statement, you will get to know for yourself why do I say this is a Heaps question, right? So yeah, let's get into this median in a data stream question. One thing I would like to say is that please do not skip this. It is a hard question. Even if you're not able to understand at some point, just go through the entire video. I can just guarantee you of this that at the end of the video, you'd know about the question, you'd understand the question entirely. And if still you're not able to understand, please use comment section. Please use the G-form link that I've provided in the description. I'll make a better video. I'll try to make you understand this in a better way because this is genuinely a tricky question and a good question if you like problem solving. Okay? So let's just go in with this question. First of all, there is a data stream. So we have already studied about the data stream in the kth largest element in the data stream question. You will like this question in a way that it is, it will make you exercise your brain muscles. So what is a data stream? Data stream is a continuous flow of data where you keep getting data in and you have to calculate whatever is asked to you in a dynamic fashion. Now let's say this is the input, right? 5, 15, 1, 3, 2, 8. So I have to calculate median when I only have 5, then I have 15, then I have 1, then I have 3, then I have 2, then I have 8. So once then here, then here, then here, then here, then here, then here. I hope you get that. Right. So one thing for the median that we all have studied in our maths classes is that the data should be arranged first in an ascending order. And second is to say that if I have an odd number of elements, let's say I have 1, 2, 3. The median is 2. And in the same case, when it's the even elements, let's say I have 2 and 3 as the middle elements, right? And then the median becomes 2 plus 3 by 2, that is 2.5. I hope you're able to understand this, but you're still not able to figure out how heaps will solve this question or why are we using heaps for this. Let's just get to that part now. So we've been given 5, 15, 1, 3, 2, 8. Okay. So first we're going to consider this as an entire data set because I'm going to explain you why heaps, right? We'll talk about the data stream later. Now let's just see this. So had we been given this as the input, what is its ascending format? 1, 2, 3, 5, 8, and 15, right? And what is the median? Median is 3 plus 5 by 2, that is 4. Make sense? Now if you see, if I draw an imaginary line to separate data, to divide the data into two equal halves, or maybe if it's an odd, we'll take that case next. If it's even, if I draw an imaginary line dividing my data into two sets, you can see this is 3 and this is 5. And I only need these two numbers for median. I don't care about 1, I don't care about 2, I don't care about 8, I don't care about 15, right? I only care about these two datas. Now, if you see what is 3, if I put all this data into my max heap, 3 is my max heap's top element. And if I put all this data into my min heap, what is 5? 5 is my min heap's top, right? So an imaginary line dividing the data stream into two parts. One part, the left part, I'm putting into max heap and getting its top, that is the maximum element from there. The min heap part, I'm putting into the right part, I'm putting into the min heap and getting its top, that is the smallest element from the right side, and then I can use this data. Now let's say I had the data that says 1, 2, 3, 4, and 5, 8, 15. Now let's say we divide it in a way that we give more elements to my left-hand side. This is the logic part. You can change it. You can add more elements to the right-hand side. That is your way. So in this case, we only have to return what? We only have to return my max heaps top. I hope you understand this. So now you somewhat, once we do the dry run, you'll understand it more clearly. But are you able to, Connect the dots right now. Why are we using two heaps and everything? Right. Because as the data comes in, we're going to store it. And then we just have to calculate the top at every consequent step. Let's just see this question. Two things that I know for sure. If my data stream is even, I have to return what? I have to return max heap dot top plus min heap dot top by 2, right? And if my data is odd, I just have to return max heaps dot top. This is the data is already in ascending order. The two things that we check for median. One is ascending order, data sorted. Second, this is what is returned. And this is as per maths, right? Now let's just go for the dry run that says 5, 15, 1, 3, 2, 8. 5, 15, 1, 3, 2, 8. Since it's the data stream, the data could be added in more. So I've told you this before. On this hand side, we have a left heap. On this hand side, we have a right heap. Left heap is going to be what? Max heap. And right heap is going to be what? Min heap. Okay. Now, then we are going to return what? We are going to return a vector. Vector not of integer. Why not of integer? Because we saw in this case, we can have decimal points as the answer. So since we can have decimal point figure as the answer, we're going to make this a vector of double. Okay. So now let's say we get 5. Once we get 5, and what are we returning? Max heap top. What is max heap? Max heap is left. And what is min heap? Min heap is right. Right. So I have to put 5 in this. Right. If my left is empty, then I will put the element that is coming in left. So I get 5. And if now the count of the element is 1. 1 is odd. Don't go by the index. Index is 0. I know. But the count of elements is 1. If it is 1, what do? I return left dot top or max heap dot top. So I get 5. Now 15. Is 15 greater than left ka top? Yes. So where do 15 goes? 15 goes in the right heap. What do I have in? 2 elements. 2 elements, even elements. What do I get? 5 plus 15 by 2. What does that mean? I get 10. Make sense? Makes sense. Now I have 1 comes in. 1 is lesser than 5. 1 goes inside this. What is the top now? What do we have to return now? We have 3 elements. 3 elements, odd. What do we return? Left top. That is 5. 3 comes in. 3 is also lesser than 5. Now you'll say, we'll keep 3 also here. But you see the division. What elements do we have? We have 1, 3, 5, and 15. Had I been drawing an imaginary line, where would that line be? Here. But here you see the line is taking 5 also to the left side. Is this possible? No. So how do I have to make the check? And if had these been my odd elements, it could have been 1, 3, 5, 15, 20. So my left heap size, so my left size, either this could be equal to right size in the first case, or it can be equal to right size plus 1, right? So that means if my left dot size comes to be greater than right dot size plus 1, what do I have to do? That is to say, I get 1, 3, 5 here and 15 here. What do I have to do? I have to pop out 5 and give this 5 to the right side. Do you get this? So what do I have to do? I have to pop out the top and put pop here and put that element here. So now what do we have as top? We have 3 from this side, 5 from this side, 3 plus 5, 8 by 2, 4. I hope you're getting it. Next, we get to the another element 2. Now, is 2 smaller than 3? Yes. I can put in here. Left size is 3. Right size is 2. Is left size greater than 2 plus 1, 3? No. So then what do we have to do? We have to take it 2. So what do I have to return? 3. Now you see it makes sense because what are the elements? 1, 2, 3, 5 and 15. Had this been a maths question, what would have you returned? 3. I hope you are able to understand it, right? Then let's come to 8. Where should the 8 go? Is 8 greater than 3? Yes, 8 will go here. What will get returned? It is like 8 gets in here. What will I get still? The top from here and the top from here by 2. 3 plus 5, 8. 8 by 2, 4. So this is what you have to return. I hope you got this question. If you still have any doubts, please post it in the comment section. If you're not able to understand this question or you want me to explain you in a one-on-one format, please just submit your query in the Google Forms that I have attached in the description box. Now let's just go in with the code format. Okay. See, first of all, what do I have to return? I have to return a vector that says double, right? And this is median in what? In stream. What do I have? I have a vector of integers told to be array. So first I have to return this. So I'll just create a vector for this. I will create answer vector for this, right? I have to create 2 heaps. One is my max heap for left division that goes by priority queue, integer left, and then I have to create a min heap for my right side, and that goes by priority queue, int, vector int, greater int, right? And this I will name as right side of the heap. Now I will keep taking 1 elements from what? From my data stream. For int I is 0, I less than array dot size, and I will keep increasing and going on to the next elements. So if my left is empty, I hope you're getting it. If my left heap is empty or array I is less than equal to my left stop, then only I will push the element into left. Else what I'm going to do? Else I'm going to push the element into my right heap. Is this much part clear with you? Now for this, I have now pushed. Next part is, now if left size gets to be greater than right size plus 1, what do I do? If left size is greater, means I have an extra element on the left side and I have to pop this element. So what do? I take my right and push in right my left's top, right? And also at the same time, I have to pop that element from left. Make sense? Right. After that, else if my left size is less than right size. Now this can never be the case. Your right can never be your right side's elements can never be greater than your left hand elements. So what do you have to do if this becomes the case? You should do opposite. Now you have to push in left, right stop, and then what you have to do? To pop it from right. I hope you get that. Right. Now we have to keep appending the elements into my output vector. So what do I do? Sorry. Okay. I'll just quickly make a change of pen. Okay. If this is all inside the same for loop. Okay. And this is why I'm doing it with only one, because I'm doing this for every element. So at max, since it's 1 element increment, we can only have the size difference by 1, right? So let's just go ahead. Now, if I %2, that is 0. If 0 is there, what is the count of the elements? Count of the elements is, if my I %2 is equal to 0, that is, let's say 0, 1, 2. This is the index 2. 2% 2 is 0, but the elements are, I have odd elements. What I have to do? I have to return. Sorry, we cannot return this way, right? We have answer and we have to push back in my answer left dot top, right? Else, now it can only be the case that I have even. I don't have any other conditionals to add, right? If the elements are even, what do I do then? I take a double val, take left stop, take right stop, then I take double value 2, let's say, and I do value 1 by 2, and then I push back value 2. Now you'll ask me, why are you doing this? Why not correct? Because, else you will have to do it how? You will have to type convert it by double and then write your left dot top plus right dot top by 2. But I feel this one a little easy. It's just my way of writing the code. You can go ahead with any way you like, okay? I know you guys may be much smarter than me, and that's absolutely making sense. Okay, so I just end this up and then I return my answer vector. I hope this makes sense to you, but if you have any concerns, any doubts, please post them in the comment section. Please use the Google Forms link to let me know of any questions you want me to take up next. They could be outside of Heaps as well. If you want me to take any subject, right now the running subject is blockchain. And if this video made sense to you, you could understand question, you could understand the problem statement, the concept, the approach, please go forward, hit like, hit subscribe. And yeah, I'm not forgetting time complexity for this time. So the time complexity is O of n log n, where n is my total elements, because it's the insertion for all of them, because popping, it's taking just O of 1. That is constant time complexity. Coming to the space complexity, we have O of approximately n by 2 for one heap, O of approximately n by 2 for the other heap, and O of n for my answer, right? And this is now something that you may take, you may not take. That is always, a point of discussion between you and your interviewer. And I believe it makes a good discussion, so that the person also knows that, okay, that you cannot, that you may also take this and you may not take this. You may take this telling that, okay, I'm using this in the question. And you may not take this telling that without this, I cannot solve the question. If I don't return in a way the interviewer wants, I cannot just solve out the question that way. So yeah, with this, I take your leave. Thank you so much. Bye-bye.